Densify.com supports 3 hybrid cloud use cases. First of all, for on-prem virtual and cloud environments, it will drive very precise workload placement and resource allocation to drive up density, drive down risk, and properly allocate resources, which saves a ton of money on both hardware and on software licensing. And all this is available through a very easy to use SaaS front end. Now, using that data, it will also do very precise transformation analysis telling you how you can migrate workloads into the cloud by looking at their exact utilization patterns against all the offerings from the cloud providers to understand which ones are the best path and the lowest cost. And the third use case is optimization of costs in the cloud. So once things are running in the cloud, it will analyze your bill in high detail and also make recommendations to right-size your workloads so you can reduce your cloud spend. And this cost optimization is critical for organizations that are either moving to the cloud or already have workloads running in the cloud. Now, this is not just for on-prem and public infrastructure as a service, it's also for public bare metal. So because Densify.com is very good at analyzing workload patterns and stacking workloads, it also can tell you whether a bare metal option is a better option for a certain set of workloads. And if you do put them there, it will do the same level of optimization it does for your virtual environments. So you can drive down the costs in bare metal, which can be a very attractive option for certain workloads. So let's go through these 3 use cases one by one. And we'll start with de-risk and densification. And what we're looking at is the SaaS portal showing us a by-the-numbers view of the environment that we're analyzing. In this case, there's 5 different locations with just over 1,000 on-prem guests and 171 cloud instances. So it's a hybrid environment, and we can see the high-level view of what this environment consists of. Now, if I go to the Insight tab, what we're going to see is more detail on what the analysis is actually saying. And here it's saying there is some risk in the environment. We're getting a view of the risk by cluster, hosts, and guests. And we're also seeing the opportunity to drive higher density. In this case, we're seeing that overall, across our entire estate, we have the ability to double the density of our workloads. We can drive up density considerably. And you see in the bottom here, it's going to free up a lot of stranded capacity. So the analysis is actually finding resources that can't be leveraged today that can be freed up and put to productive use. So you're getting a big efficiency gain by analyzing your environment and taking the actions it's saying. We're also getting a forecast view of how much available capacity we will have and where risks might crop up in the environment. So it's a predictive view of the environment, not just for right now, but 30, 60, 90 days into the future. Now this is the high-level view. I can also drill down and see more detail in each of these sections. So in the de-risk section, what I will see is a view of the cluster, hosts, and guest level risk, with drill downs telling me exactly where the risks are and what the actions are to remediate. And I can review those actions, or I can just tell it to do them automatically, and there's full automation using Densify.com. We can also see a view of our progress over time across the bottom here. You can see that we are making good progress on reducing our risks at each level. That's very important. A lot of organizations want to see if they're actually meeting their goals and making the environments better. So we get a detailed risk view and also a detailed density view. And this tells us more of our opportunity. It's telling us what spare resources we have and how much we can free up through the analytics. It's telling us more detail into each environment and where the opportunity is to drive density. And it's also telling us our licensing opportunity. So this not only drives up density of the hardware, but also it will reduce your software licensing requirements. And there's significant gains to be had by placing the workloads in a way that minimizes the software footprint. So again, very detailed views. There's drill downs here that go right down into each environment and exactly what to do to achieve those gains. Now you'll notice there's also expert insight in these areas. You notice that in the cluster level, there's 3 insights. And Bob here is our densification advisor. So Densify.com is not just analytics software. It actually includes advisors that are specialists that help guide you and curate the answers and tell you what to do. And he's giving us a bunch of different insight here. For example, the middle one, he's telling us that your policy is only set to 80%, and that's limiting workload density. Other customers typically run 90%. So Bob works with lots of customers. He understands the strategies at work, and he's telling us that you have a policy setting here that might be limiting your density. So you can gain by what others succeed in doing. And again, Bob is your path to that. He's got your back as far as understanding what your opportunities are and how to get there. Now that's the de-risk and densification section. Let's move on now and talk about transforming to cloud. So with all this data that we're gathering for all the workloads, we're able to do a very detailed analysis against different public cloud hosting venues to tell you where the optimal hosting venue is for a set of workloads. And I can filter down on different sections of my environment, different groups, different apps. I can also group by application or different logical boundaries. In this case, we're looking at a cluster level view. And I can see for each of those groupings, what is the optimal hosting venue. and can choose a set that I'm going to compare. So you see here that we're doing comparative analysis. We're looking at this Houston environment, and we get to see for the 3 venues that we've selected which one is best. And in this case, SoftLayer is coming out on top. So it's actually the cheapest to run that set of workloads. If I go down the list and look at New York, it's a different answer. And this entirely depends on your workloads. So the New York environment is running a different mix of applications, and based on the actual workload patterns, it's cheaper to run in Amazon East. So you might see a different answer for each environment, and you can look at these different ones, different strategies for different apps, or you can just use this to choose the best overall cloud hosting environment for your organization. But in this case, you can see you get a very detailed view of what the costs are going to be for each one. Now, if I go to this Houston environment, we'll see something interesting. We'll see that in this case, SoftLayer is the best option, but not everything can go there. And you see 10% of the workloads can't go there. In this case, it's because 2 of these environments are in the US and 1 of them in Canada. And this app may have data residency requirements. That means that a bunch of the VMs can't actually go there. So this is not just looking at the workload data alone. It's looking at the fit for purpose requirements in your governance policies to understand, can that app actually go to that venue, or are you going to violate some governance policy that you may have? Now I can drill down into the next level of detail here. So you see this has 59 total guests, and I can click there and I can actually see the guest by guest detail. And this just shows the power of this analysis. So this is telling us that this first VM, we're recommending it go on a 4x4 instance in SoftLayer. And that's because we're actually looking at the actual utilization patterns. So this is the CPU pattern for this workload. And you can see it does a little bit of activity throughout the day and then has a spike out to about 50% at 6 p.m. So it's not using all the resources in your on-prem VM. And we're going to use that to actually accurately size the cloud instance. And we look at the CPU, the memory, the disk I/O, network I/O rates, all the vital stats to make sure that we understand exactly how to size that in the cloud to get the best cost. Now, interestingly, we chose a strategy here where we're saying let's choose the best venue for all of these workloads together, but it'll also tell you on a 1-by-1 basis what the optimal venue is. And for this particular workload, if you were doing it alone, it would actually be cheaper to run it in an Azure Basic A3. So Azure has a slightly better fit for this particular workload, but overall, we don't want to run one workload in one cloud, another one in a different cloud. So we're saying overall, SoftLayer is the best choice for this grouping. But you can slice and dice this any way you want. And you can see as I go down here, each workload is different. This one has a different CPU curve, different I/O characteristics. So its CPU is a little more biased towards the overnight hours. This third one on the list, it ramps up throughout the day and has a very high disk I/O activity. So all of this is used to figure out where the best hosting venue is for each individual component and the groupings as a whole. So let's go back out to our top level view now, and really the purpose of this view is to create move groups. So I want to be able to divide my environment up, find different areas, different candidates, and different groupings, and then ultimately use this to create move groups. And if I go to the move groups section, you'll see some move groups that have already been created. And this is where you can design transformation waves. So a move group is really a set of candidates that are going to a common location at a certain time. And so here you see we've created 2 different waves here. One in January for a bunch of workloads going to SoftLayer, one in February for a bunch of workloads going to Amazon. And I can see the dates and the costs and the number of guests that are going in there. And you can see here now that I actually have a bit of insight on here. So I also have a transform advisor that's looking at my plans and giving me advice on what might work. And if I click on this insight, Janet here is telling me that a lot of the workloads in this group are very peaky in nature and only use resources for a limited duration and even at different times of day. And she's giving us some examples here saying here's one workload that's busy late in the day, and there's another one in the same environment that's busy early in the day. And like a good game of Tetris, these might go nicely together. So she's actually recommending that we consider bare metal with a hypervisor for these workloads. And we see that quite a bit, where certain workloads that have certain peaky patterns might stack well together and benefit from overcommit. So that's an important strategy, and we can actually do that analysis right from this console. So even though I've analyzed and said, well, of my public infrastructure as a service option, SoftLayer Virtual is the best one, I can also analyze onto bare metal or even into containers. So I can say, let's take these workloads and see what they look like running in a VMware environment on SoftLayer bare metal, where I'm renting the blades instead of the individual instances. And you can see we also have support for VMware on AWS. We're just waiting on the pricing for that and the specs for this hardware, and that will light up and you'll be able to do that analysis as well. I mean, we think that's going to be a very hot topic when it's available. So I can take any set of workloads and say, what does that look like if I run it in a bare metal option? And in this case, all 52 instances can run on 5 physical servers in SoftLayer for about $5,600 a month. So that's a lot cheaper than renting 52 individual instances, small, mediums, and larges. And we see that a lot, where when you run this analysis, it's actually a lot cheaper if you can overcommit resources. And you see here, we're going to get a lot better utilization overall than if we rent individual containers for each workload. So that's a very important strategy. We see bare metal getting discussed a lot with Amazon and VMware announcing a solution together. We think that's going to be a hot topic in 2017. And that's our densification advisor kind of giving us a heads up that this might be a candidate to do that with. Now, ultimately, what I want to do is to get to a very specific plan, and I want to promote that to the routing system. And that goes into Densify's routing and reservation system, where it becomes a concrete plan. It becomes part of the forecasts. Those workloads will get booked out of the environments that they're in. It'll free up capacity. All the predictive modeling will be done once we promote that to become an actual routed application. So we get a complete end-to-end view of the transformation, including predictive views of what we're going to look like 30, 60, 90 days from now. Now that's a transform to cloud use case. Now, once you moved on from that, once you've moved things in the cloud, or if you already have things running in the cloud, a lot of organizations need accountability for what they're running in the cloud and more detail into their bills. So if I go to my optimized cloud costs section of Densify.com, what I'm going to see now is an analysis of my actual costs in the cloud back through previous months. And you can see on this film strip indicator at the top here, I'm looking at November, but in October, I had an actual cost of $26,000, and I can click there and zoom in on that month in my history. And you can see here we were slightly above our budget, and you can drill down here and look at all the contributors to the cost. So I can see my bill broken down by who consumed those services. So there's full tagging to understand which lines of business or applications consume those resources, and what services the money was spent on, whether it was compute or storage or data transfer costs. All that is broken down. So a complete analysis of your cloud bills to understand where the money is going. I can also look at more detailed cost allocation. I can get a view by choosing a time range and saying, tell me what each group spent money on in a more tabular form. And very importantly, I can set budgets. And these budgets might be based on specific budgets I want to enter, or they may be based on an automatically computed baseline based on your history. So you can set up baseline budgets to understand when you're running over what you need to. And we see a lot of organizations that have a bit of sticker shock when they move things into the cloud. So the idea here is that you can get complete visibility into what you're doing in the cloud, and through the transform analysis, not be surprised in the first place, because you're predictably understanding what your costs are going to be. Now, if I go back to the cost summary, you see in this section we also have some insight. So if I click on this insight for October, we see that Raj is our cloud cost advisor. So you can see in Densify there are different types of advisors. And Raj is an expert on cloud costs, obviously. And in this case, he's giving us a little bit of insight, saying that there were some higher than normal costs in the month of October. And these were due to some new EC2 instances and an increase in data transfer activity. And he's being very specific. So the idea here is that Raj, you may be too busy to look at your bill in detail. Raj, that's his job. He's going to look at it and tell you from October 3rd to 5th, you had a lot of data transfer activity for the image archive application. So that's extremely useful information. So he's using the analytics and giving insight and just letting you know about that, so you don't have to spend your time reading all these bills every month. And if I look at Raj on the bottom left here, he's actually giving us some other insight as well around our cloud costs. So if I look at all the insight he's giving us, he's also saying that based on the usage pattern in Amazon West, he's recommending that you reserve 6 M4 larges. And he's actually giving us the pattern. That's your pattern of activity of how you've been using, how many instances you've had turned on. And he's saying if you do that, you're going to save over $200 a month. And he's done an analysis, and reserving 6 is the best option. It's the kind of the break-even point where you're going to get the best possible cost. And we do see a lot of customers struggling to understand how to reserve instances. It's very complex. It's different for each application. It depends on the pattern of activity. So again, with the analytics combined with Raj's expertise, you're able to get insight into that. So that's all available through the SaaS portal. So again, it's a combination of detailed analytics and expert insight that come together to give you a very, very easy to use, very deep experience in all three of these areas. And basically optimizing and densifying and de-risking your running environments, figuring out how to transform into the cloud, and then when you're in the cloud, how to optimize your spend and minimize your spend so you're not wasting money in the cloud. And all this is available through one SaaS portal through Densify.com.